Okay, and more examples for 4.5. All right, so let's do some trig. So you have the integral of sine of x over cosine cubed of x dx. Okay, so I like to rewrite this as parentheses cosine of x and then parentheses cubed. Okay, so you got that, and then you can rewrite it to be 1 over that times sine of x. Okay, this combines together to give you this one. This will help some of you all figure out what's the innermost thing. Okay, so the innermost function is the cosine of x, all right? And one way to test that out is just think about, could you take the derivative of cosine and get sine, which you can. All right, so u is cosine of x, so derivative of u would be du, derivative of cosine is negative sine of x dx. This is a positive sign though, so we're gonna have to divide this negative 1. So you have negative 1 du is our sine of x dx. Okay, so you just go in and you simplify. So 1 over cosine of x cubed becomes 1 over u cubed. Sine of x dx becomes the negative 1 du. Okay, you can move the negative to the outside. So you have, I'm going to rewrite this as u to the negative third du. Alright, so bring that negative 1 along. The antiderivative of u to the negative third is u to the negative 2 divided by negative 2 plus c. Alright, so then you can substitute u back in with cosine of x. So it's cosine of x to the negative 2 over 2. These negatives are going to cancel each other out. And then plus c. And then a negative exponent actually takes it to the bottom of a fraction and makes it positive. So it's 1 over 2 times cosine of x squared plus c. Alright. So let's look at one of these examples where there's an extra x to deal with. I think it's example 5 in the reading. Okay, so this one is from the homework section though. So you have to take the integral of x squared times the square root of 1 minus x dx. Okay, so the u is the 1 minus x. Du would end up giving you negative 1 dx, which is not anywhere in the problem. So you're going to have to divide by negative 1. So negative 1 du is our dx. Okay, so if you notice, you can replace this now with u. You can get rid of this and put negative 1 du, but we have this x squared out here. Okay, so you know that u equals 1 minus x. So you can actually solve for x in terms of u here, okay? So if you subtract 1, and then you're going to divide by negative 1 on both sides. So x is actually equal to negative u plus 1, all right? So whenever you have a problem like that where you have an extra x that's just not going to go away, you can solve for it in terms of u, and then put that in. So for x squared, we're going to put negative u plus 1 squared, okay? Then the square root of this part, it just becomes u to the 1/2 because it was the square root of u, times that negative 1 du. So the negative 1 moves to the outside. The negative u plus 1 is going to get squared, so I wrote it out twice so I can FOIL it, and then we have u to the 1/2 du. Alright, so when you FOIL this out, you get u squared minus 2u plus 1, and then we're going to distribute the u to the 1/2 in there to everything. Okay, so you distribute that in. And then you're going to take the antiderivative of everything. So the antiderivative of u to the 5/2 is u to the 7/2 times 2 over 7. U to the 3/2 becomes u to the 5/2, and then you're going to have to multiply this 2 by 2/3. Multiply it by 2/5, okay? So you do that part, all right, and then this becomes u to the 1/2 antiderivative is u to the 3/2 times 2/3. Okay, the negative is still out here. So then when you do your final answer, you're going to have to distribute the negative to everything. So this is going to become negative, this term is going to become positive now, this term is going to become negative, okay? And then I replaced all the u's with the 1 minus x.